Welcome to the video on significant tests in practice, chapter 12, just a continuation of chapter 11, really. So in this section, we'll do t-tests, and this is when you don't know the population standard deviation. So just like z-intervals and t-intervals, for means, same thing. We're only going to use a z-test if we know this population standard deviation, and really that we're not going to do that. So in general, you'll be using t-tests because you don't know the population standard deviation. And so here is the equation for your t-score, same as before, as for the t-interval. It's your sample mean minus, this time, your null mean, which is your mu sub 0. The sub 0 just isn't written there. And divided by your standard deviation of your sample over the square root of your sample size. And you need to know your degrees of freedom, which is your sample size minus 1. This slide is just showing you how to calculate your p-value if you don't use the t-test. So if you find your t-score and you want to know the p-value and you are doing a greater than statement in your alternative hypothesis, you would do your t-score to infinity. If you were doing your less than, you would do negative infinity to your t-score. If you're doing two-tailed, you can just find one side and then double it because it's going to be symmetrical. If you use the t-test button in your calculator, no worries, you will get the p-value out from your t-test. All right, and this is under your stat test option. It's right below the z-test button. All right, here's our first example. So I would pause the video for a second, type these 5 data points into your calculator, and then press play again. Okay, so this problem is about a college counseling center is concerned students aren't taking advantage of the services, and they only attend about 4.6 sessions in a given year, and they want to see if making students sign a contract to attend 10 will increase how many sessions they attend. So we are going to do a hypothesis test on this. And so first thing, you write your null and alternative like before. As I've said, I've taken to more defining mu up here and then not writing it next to each one separately. So I would just like mean number of sessions attended. And then I would just not write it next to each one after that. You can do it both ways. I've just changed how I've started doing it. All right, the conditions, randomization, stated in the question. Normality, obviously, 5 is not less than 30. Now, the problem is if you graph this, it's really hard to tell with 5 data points if the data is going to be skewed or if it's approximately normal. So really, with such a small data set, I would just point out it's small data set and that you need to be cautious about that. In real life, 5 data points is not enough. The independence is not here. It should be, so let me add that, independence, because this was a sample. So they were applying a treatment of a contract like an experiment, but they really weren't, they didn't have a control, and it's kind of a weird thing. So it's hard to tell if this is really an experiment. It's a weird like in between question. So if we do 5 times 10 less than the population, so you just need to assume there's more than 50 students getting therapy. All right, so here's the calculations all in there, and then you got the probability that t is greater than 2.87, and we get 0.02, which is less than the normal acceptable alpha level of 0.05. So there's statistically significant evidence that the contract makes people attend more therapy sessions. All right, We're going to do one more example, and that's a match pairs t-test, pre versus post test. This has more data points. So really what we care about is the difference column. And so you're just going to put the difference column into your list one. And we are looking at if student scores improved post minus pre-test. So basically after they were taught something, did they do better than before they were taught something? So pause the video and just put that difference column in. You want to list one, let's say, to do the t-test. All right, so the null and the alternative are written like this. Now the subscript is your friend on match pairs, and you want to make sure that you define what order you're subtracting things, because that's usually what you're doing in a match pairs. And so I'm doing post minus pre. Do not write it as mu post minus mu pre. That's actually a two sample test because you're taking the mean of the post test minus the mean of the pre-test. And that is different than taking the mean of the differences, which is what this notation does. So it's minor difference, but it's an important mathematical difference in the order of operations. So make sure for match pairs, you define the order of subtraction by saying the mu diff is equal to whatever order of subtraction you do. If you're afraid you're going to make notation mistakes, you could do it in words and say mu diff equals the mean of the post-test minus the pre-test. Oops. So you can do it in words if you're concerned about your notation. And then the null, pretty much for almost all match pairs, the difference is your null is that the difference there is zero. There's no change between one thing and the other. And then we're hoping that the post test, they just score better. So we're hoping that it's greater than zero. And then we can check the conditions, same as normal. Here is this box plot and normal probability plot looks beautiful. And the independence check, we have to assume there's more than 200 students. And then the calculation, I'll write it out a little bit nicer so that you can see in non-Microsoft type. So this is our t-score, and that equals 3.23. And our degrees of freedom, you need to write that down as well for when you do the calculation. Write the degrees of freedom out. Besides just the t-score, it's good to just write degrees of freedom equals, like I have there, 19. And so our p-value when we run the t-test in the calculator comes out to 0.002. And then our interpretation, same as always, it's less than the alpha value, therefore we can reject the null, and there's statistically significant evidence that the teacher teaching makes people do better. It's a crazy. All right, so that's all that we have for a t-test. We'll do some more practice in class, and if you have calculator questions, we will go over those in class.